Okay, here is the third of the Ansys projects for this semester. For this one, we are going to do an inviscid flow, a laminar flow, and a turbulent flow all around a cylinder within our region. So for the sketch and the meshing process for all three flows are the same. So it's going to be a short little segment here. It is going to be a 1 meter circle inside of a 50 by 50 meter box. And that's just using the circular tool and the rectangular tool. And once that, we come over here to meshing. The meshing is all the same. So the first thing you're going to want to do is you want to go right click, insert, and then method. You're going to want to have the whole body as your geometry. You're going to want to change your method to triangles. And then you're going to want to go back, right click, insert sizing. Right click, insert sizing here. And then you're going to want to have your geometry as your cylinder. You want to change your type to number of divisions. Have your number of divisions as 200. Have capture curvature no, and then behavior hard. Generate. And then you're going to want to do inflation. So right click, insert inflation. You're going to want to choose your geometry here as the entire face. And you want to choose your boundary here, down here, as your cylinder. You're going to want to change your inflation option to first layer thickness. I used 0.003 in this case. You want to change it the maximum layers to 100 and generate. Then it should look not quite as detailed as this. You'll still have some triangle bits up here. And to get it as fine as this, you're going to want to go down under mesh, down to element size. I changed it to 0.15. And then once you change that, it'll look something like this. And like I said previously, the mesh is the exact same for all three flows that we're doing today. Then I did the name selections. This is also the same for all three. The velocity inlet at this wall, the pressure outlet at this wall. I just chose the top and bottom wall. I just named it symmetry. And I wanted to save the name wall for our cylinder here. So once you're there, go back to workbench, go into setup. Setup. This is where things differ among the three flows. So under models for inviscid flow, you're going to want to come here, go viscid or viscous inviscid. For the laminar and turbulent flows, you're going to want to choose laminar here. But for inviscid, choose inviscid. For the other two, laminar. And then you want to go to materials, fluid, air. For all three flows, I kept this the same. For inviscid, you're going to only have density. I kept it at 1. I used 1 as the density in the other two flows as well. But when you choose laminar under models, it'll also give you the viscosity. The viscosity, I put 1 E minus 5 for the other two flows. I kept that constant. Then onto the boundary conditions. The velocity inlet. This is a major difference between the three flows. For the inviscid flow, I chose 5 meters per second. For the laminar flow, for the Reynolds number to be under 500,000 for external flow, I chose 1 meter per second. And then for turbulent flow to have that Reynolds number over 500,000, I chose 25 meters per second. It would be apply, close. come down to reference values. Let's come up here, density, pressure should be 0, area 1, because your area here is 1 meter squared. Your depth is 1 meter. Your length, your diameter of your cylinder is 1, and your depth is 1 meter. Therefore, it'll be 1 meter squared for the area. Density is the same for all three flows. Like I said, 1. The viscosity will be 1 in the laminar and turbulent flows, and then the velocity will show up here. And just make sure that is the same as the one you put in your boundary conditions. In this case, I have the inviscid flow up, so it is 5 meters per second. But for the laminar flow, this would have been 1, and then for turbulent would have been 25. And then initialization, hybrid initialization. For this one, I did 25 iterations for all three initializations, just for pure accuracy. And calculation, I chose 1,000 iterations for both laminar and inviscid. I did 500 iterations for turbulent, just for the sake of time, and just for the sake of time of calculating and having it run on my computer. I guess that's all I have for you today. Thank you.